In 1972, a miner in South Africa held something in his hand that shouldn't exist. A metallic sphere, perfectly grooved, balanced so precisely that it could roll in a straight line across a table. But here's the problem. The rock that imprisoned it was 3 billion years old. When that sphere was somehow placed inside that stone, Earth was a toxic bacterial soup. No plants, no animals, nothing even remotely capable of precision engineering. And yet, there it was. What if I told you that sphere is just one of hundreds? What if I told you we've found impossible objects buried in coal seams, locked in Antarctic ice, and embedded in rocks older than dinosaurs? Objects that whisper a single, terrifying question. Are we really the first? Stay with me until the end of this video, because what we uncover in Chapter 6 will completely change how you see human history. But first, we need to talk about what scientists are too afraid to say out loud. There's a hypothesis. Most people have never heard of it. It's called the Silurian hypothesis, proposed by NASA astrobiologist Gavin Schmidt and astrophysicist Adam Frank. It asks, if an industrial civilization existed on Earth millions of years before humans, would we even know? The answer is chilling. Probably not. Cities crumble in thousands of years. Steel rusts, concrete powders, glass melts back into sand. Give it 1,000,000 years, and every skyscraper, every highway, every monument we've ever built will be gone. Completely erased. But some things survive. And that's where it gets weird. Let's go back to those spheres, the Klerksdorp spheres, as they're called. Miners found them in pyrophyllite deposits in South Africa. Some are smooth. Others have 3 parallel grooves carved around their equators with laser-like precision. Under analysis, they're made of hematite and other metallic minerals in ratios that don't occur naturally. Geologists say they're concretions, natural formations where minerals cluster under pressure. But concretions don't have perfect grooves. They don't balance like ball bearings. And they certainly don't show up by the hundreds in the same formation. Then there's the Kozo artifact. In 1961, rockhounds cracked open a geode in California, and inside was what looked like a spark plug. Porcelain, copper, a metal shaft. The rock around it? 500,000 years old. Mainstream science dismisses it as a 1920s spark plug that got encased in fast-forming sediment. But the people who found it swear the rock was solid, ancient, untouched. Or consider the Wolfsegg iron, a small cube of iron pulled from Austrian coal in 1885. It had a deep groove running around it, as if machined. The coal it came from was 60 million years old. That's 60 million years before humans, before primates, before anything with hands. Here's the thing. If we vanish tomorrow, what would remain? In 1,000,000 years, archaeologists wouldn't find our phones or our cars, but they would find our nuclear waste, our microplastics, our isotopic fingerprints in the soil, and scattered through the sediment. Tiny metallic beads. The same kind is created when nuclear bombs vaporize stone and metal, then rain it back down as microscopic spheres. We're leaving those behind right now, billions of them. So when we find ancient spheres that look identical, when we find machined metal in coal older than mammals, we have to ask, what if they left the same evidence we're leaving? But objects in stone are just the beginning, because if an ancient civilization rose and fell, they wouldn't just leave artifacts. They'd leave something far more permanent, something written into the very atoms of the Earth itself. And that's exactly what we found. Soon we will be diving into the atomic ghosts, radiation signatures that have no right to exist. If you want to see the evidence that even skeptics can't explain, you need to stay until the end. Hit that subscribe button to keep getting videos like this every day, and let's keep digging. Nuclear fire leaves a signature, an atomic fingerprint that cannot be erased, cannot be hidden, cannot be explained away by wind or water or time. When you split an atom, you create isotopes that don't exist in nature, ratios of elements that betray exactly what happened. And here's the unsettling truth. We're finding those signatures in rocks that predate humanity by millions of years. In 1972, the same year those metallic spheres were discovered in South Africa, French scientists made another impossible discovery in Gabon, West Africa. Inside a uranium mine at Oklo, they found something that shook physics to its core. The uranium had already been used. The isotope ratios looked exactly like spent fuel rods from a nuclear reactor. But this wasn't a modern reactor. The reactions had occurred 1.8 billion years ago. Geologists scrambled for an explanation. They found one. Groundwater had seeped into uranium-rich deposits, slowing neutrons just enough to sustain a natural chain reaction. Nature had accidentally built a nuclear reactor, and it proved something crucial. Nuclear signatures last forever. Even after nearly 2 billion years, the isotopic evidence was crystal clear, unmistakable, permanent. But if natural reactors can exist, what else might look natural but isn't? Here's where it gets darker. Across 6 continents, geologists have found radioactive isotopes in concentrations that shouldn't exist. Plutonium in Greenland ice cores is hundreds of thousands of years old. Cesium and strontium in sediments from the Pacific Ocean floor, locked in layers tens of millions of years ancient. These are isotopes modern reactors produce under tightly controlled conditions. Isotopes that don't form naturally. One sample pulled from deep Antarctic ice contained plutonium-244, an isotope so rare it requires advanced nuclear technology to create. That ice was 400,000 years old. 400,000 years before the first human city, before agriculture, before pottery. Someone or something left radioactive breadcrumbs in frozen time. Then there are the glass deserts. When the first atomic bomb detonated in 1945 at Trinity Site, New Mexico, the sand beneath ground zero melted into green radioactive glass called trinitite. It's a unique formation, created only by the intense heat of nuclear explosions. Scientists use it as a marker of the atomic age. But in the Sahara Desert, there are vast fields of yellow-green glass scattered across the sand, Libyan desert glass. Some pieces are gem quality, used in ancient Egyptian jewelry, including a scarab in King Tut's tomb. The official explanation? A meteorite impact or airburst 29 million years ago. But the chemical composition doesn't match impact glass, and the distribution pattern looks disturbingly like blast radii. Similar glass fields exist in the Gobi Desert, in parts of the Middle East, in Scotland. Each one was explained away as a natural phenomenon, yet each one bore an eerie resemblance to nuclear test sites. Ancient Sanskrit texts describe weapons that sound impossible. The Mahabharata speaks of Brahmastra, a weapon that made the sky glow like 10,000 suns, that left survivors with their hair and nails falling out, and that poisoned food and water. For centuries, scholars called it mythology. Then we invented nuclear weapons and recognized the symptoms: radiation poisoning. In the ruins of Mohenjo-Daro, an ancient city in Pakistan, archaeologists found skeletons scattered in the streets as if people had died instantly mid-stride. Some bodies showed radiation levels 50 times higher than normal. The city stones were partially vitrified, melted by extreme heat. No signs of invasion, no volcanic activity, just sudden death and melted rock. Mainstream archaeology blames a sudden epidemic or rapid abandonment, but the heat signatures tell a different story. The atomic ghost is real, it's measurable, it's scientific. When civilization falls, the atoms remember. They remember for millions of years, whispering secrets in isotopic ratios that only modern science can decode. And if atoms remember the splitting of the nucleus, if they remember fire hot enough to turn sand into glass, if they preserve the fingerprints of technologies we thought were ours alone, then what else does the Earth remember? What other secrets are written in stone, ice, and bone, waiting for us to ask the right questions finally? Because the evidence isn't just in radioactive rocks, it's in the very air we breathe. If you want to hide a murder, you don't leave the weapon behind. But what if the weapon is the atmosphere itself? What if the crime scene is the entire planet, and the evidence is locked in ice, sediment, and air that's been holding its breath for millions of years? In Greenland and Antarctica, scientists drill deep into glaciers, pulling up cylinders of ice that are time capsules. Each layer contains bubbles of ancient air, perfectly preserved snapshots of Earth's atmosphere going back 800,000 years. When we analyze these bubbles, we can see carbon dioxide levels, methane concentrations, and temperature fluctuations. It's like reading Earth's medical records. And there are scars we can't explain. Deep in the ice cores, researchers have found sudden, violent spikes in carbon dioxide. Not the gradual rises and falls of natural climate cycles, but sharp, unnatural jumps that look disturbingly familiar. They look exactly like what we're doing right now. Burning fossil fuels releases a specific isotopic signature of carbon, lighter than what volcanoes produce, and in some ancient ice layers, that signature appears. The fingerprint of combustion on an industrial scale, frozen in time millions of years before humans existed. Official science points to volcanic mega-eruptions or methane releases from thawing permafrost. But the patterns don't quite fit. Volcanoes release carbon in pulses over thousands of years. These spikes are fast, concentrated, and industrial. Then there's the plastic problem. In 2019, oceanographers drilling into Pacific Ocean sediments found something impossible. Polymer-like fragments in layers dated to 30 million years ago. At first, they assumed contamination, drill bits, storage containers, and lab equipment. But the fragments kept appearing in sealed, undisturbed cores. Some were buried too deep, in sediments compacted long before humans evolved. Under electron microscopes, these fragments showed repeating molecular chains, organized structures that don't occur in natural resins like amber or fossilized tree sap. They looked synthetic, engineered, as if someone had invented polyethylene tens of millions of years before we did, used it, discarded it, and let the ocean bury the evidence. And they're not alone. Researchers have found metallic microbeads in ancient rock, alloys of nickel, chromium, and iron in ratios that mirror modern stainless steel. Tiny fragments of what looks like concrete in Cretaceous sediment. Chemical signatures of fertilizers, pesticides, and industrial solvents in soil, layers that predate the dinosaurs. The Earth keeps receipts. Every chemical we create, every molecule we synthesize, every compound we release into the environment becomes part of the geological record. Future scientists won't need to find our cities. They'll find our garbage, our pollution, our chemical fingerprints pressed into stone. Which brings us to the greatest climate mystery of all, the Paleocene-Eocene thermal maximum, or PETM. 56 million years ago, Earth suddenly became a greenhouse. Temperatures spiked by 5 to 8 degrees Celsius in just a few thousand years. Oceans acidified. Species went extinct. It took 200,000 years for the planet to recover. The culprit? A massive release of carbon into the atmosphere. But here's the problem. The amount of carbon released and the speed at which it happened don't match any known natural process. Volcanic eruptions couldn't pump out that much that fast. Methane release from ocean floors doesn't explain the isotopic ratios. Even asteroid impacts don't fit the timeline. But industrial civilization does. If a technological species had burned through its fossil fuels, cleared its forests, and pumped greenhouse gases into the sky at an accelerating rate, the PETM is exactly what it would look like. A runaway climate disaster caused by a civilization that couldn't stop itself. And when it was over, the planet reset. Life adapted. and the evidence of who caused it slowly dissolved into the sediment, leaving only chemical echoes. We are doing the same thing right now. Atmospheric CO2 is higher than at any time in 3 million years. Oceans acidifying. Plastic is in every ecosystem on Earth. Synthetic chemicals in the rain. Future geologists will drill into our layer and find the same signatures we're finding in the PETM. The same patterns we're puzzling over in ancient cores. The Earth keeps receipts. It writes every crime into stone, ice, and air. The question isn't whether the evidence exists. The question is, can we read it? And if we can, are we brave enough to see what it says about us? Evolution is supposed to be slow, gradual. Species adapt over millions of years through tiny mutations and natural selection. That's the story we've been told. But when you actually look at the fossil record, what you see is something else entirely. You see explosions of complexity, sudden appearances, and then silence. Mass death on a scale that feels less like nature and more like something went catastrophically wrong. 540 million years ago, life on Earth was simple. Bacteria, algae, soft, worm-like creatures drifting in primordial oceans. Then, in what geologists call an instant, everything changed. The Cambrian explosion. Within just 10 million years, a blink in geological time, nearly every major animal group appeared fully formed. Eyes, shells, nervous systems, complex predators and prey. Dozens of new body plans emerged out of nowhere, as if someone had flipped a switch. Darwin himself called it one of the greatest objections to his theory. Where were the ancestors? Where were the transitional forms? They should be everywhere in the fossil record, but they're not. It's as if life jumped from single-celled organisms to complex animals overnight. Mainstream science explains it as a perfect storm of environmental conditions. Oxygen levels rose, ecological niches opened up, genetic toolkits suddenly allowed for rapid diversification. And maybe that's true. But when you see the same pattern repeat again and again throughout history, sudden leaps followed by long plateaus, you start to wonder if something else is shaping life on Earth. Fast forward to the extinctions. Earth has experienced 5 mass extinction events, moments when most species on the planet simply vanished. The Great Dying, 252 million years ago, wiped out 96% of marine life and 70% of terrestrial species. The asteroid that killed the dinosaurs 66 million years ago erased 75% of all species in a geological instant. The official explanations are asteroids, volcanoes, and climate shifts, acts of nature. But look closer at the patterns. Some extinctions don't fit. The end Permian extinction, the worst of all, shows chemical signatures in the rocks that look disturbingly industrial. Massive releases of CO2 and methane, ocean acidification. Global warming is spiraling out of control. It looks less like a volcanic mega-eruption and more like a runaway greenhouse effect caused by something burning through resources too quickly. And here's the chilling part. In several extinction layers, we find those metallic microspheres again. The same spheres that form in nuclear detonations. Isotopic anomalies that don't match asteroid impacts. Sudden disappearances of species that thrived for millions of years, gone in what looks like a single catastrophic event. What if some extinctions weren't cosmic accidents? What if they were technological collapses? This brings us to the Great Filter, a concept from astrobiology that asks a haunting question. If intelligent life is common in the universe, where is everyone? Why don't we see evidence of alien civilizations? The answer might be that most civilizations destroy themselves before they reach the stars. They hit a filter, a barrier that few survive. Nuclear war, climate collapse, resource depletion, artificial intelligence. Something stops them. And the terrifying implication is this: if the Great Filter is real, we might not be approaching it. We might be in it right now, because civilizations are geological forces. When intelligence arises, it doesn't just adapt to the environment, it reshapes it. We've moved more Earth through mining than all the rivers and glaciers combined. We've altered the atmosphere faster than any volcanic event. We've created materials that will last millions of years. We are a mass extinction event in progress, leaving signatures that future scientists will puzzle over, just as we puzzle over ancient anomalies. If other civilizations rose on Earth before us, their extinctions would look exactly like the ones we see in the fossil record. Sudden, chemically strange, marked by isotopic fingerprints and atmospheric scars. And then life resets, new species evolve, the planet heals, and the cycle begins again. The fossil record isn't just a book of life, it's a ledger of failures, of civilizations that rose, burned bright, and then blinked out, leaving only chemical ghosts and extinction layers as their tombstones. If they rose and fell, if they reached for the stars and collapsed back into the stone, then the next question becomes unavoidable. Where did they go? What happened to their cities, their machines, their bones? And the answer might be closer than you think. On Earth, everything erodes. Wind wears down mountains. Rain dissolves stone. Tectonic plates swallow continents whole. Give it a few million years, and even the most enduring monument becomes dust. But there's one place where evidence never fades, a place with no weather, no erosion, no oceans to bury the past, a place where a footprint can last 1 billion years, the Moon. When Neil Armstrong stepped onto the lunar surface in 1969, he left behind a boot print that will remain pristine for millions of years. No wind to blow it away, no rain to wash it clean. The Apollo landing sites, the flags, the rovers, all of it will sit exactly where we left it long after every trace of humanity has vanished from Earth. The Moon is the ultimate archive. And if we've only been going there for 50 years, what might others have left behind in 50 million? In the 1970s, amateur astronomers began reporting strange flashes of light on the lunar surface. Not impacts, not reflections, brief, localized glows that appeared and disappeared in the same craters again and again. NASA called them transient lunar phenomena and attributed them to outgassing or static electricity, but some researchers wondered if we were seeing something else. Machinery, power sources, remnants of structures buried just below the dust, occasionally catching sunlight or activating for reasons we don't understand. Then there are the lunar glass beads. Scattered across the Moon's surface are millions of tiny spheres, officially explained as impact melt from asteroid collisions. But some concentrations don't match impact patterns. They cluster in geometric arrangements. In certain craters, they form what look almost like roads or foundations, lines of glass beads stretching for kilometers in unnaturally straight patterns. Could ancient civilizations have mined the Moon? Could they have built bases in lava tubes, those massive underground tunnels that honeycomb the lunar subsurface? If they did, their structures would still be there, protected from solar radiation and micrometeorites, waiting in the dark. But the Moon is just the beginning. Mars tells an even stranger story. Billions of years ago, Mars had rivers, lakes, and possibly oceans. Its atmosphere was thick enough to support liquid water. If life evolved there, intelligence might have followed. And when NASA's Viking orbiters sent back photos in 1976, one image stopped the world: the face on Cydonia, a mesa in the Martian desert that, in low-resolution shadows, looked like a giant carved face staring up at the stars. Later, high-resolution images revealed it as a natural formation, pareidolia, our brain's tendency to see faces in random patterns. But the excitement it caused proved something important. We are ready to believe. And Mars keeps offering more mysteries. Pyramidal structures in the Elysium region, geometric formations that look almost artificial, mineral deposits that suggest water was processed, not just present. What if Mars had a civilization that collapsed when its atmosphere was stripped away? What if their ruins are buried under kilometers of dust, invisible to orbiters but waiting for rovers to dig just a little deeper? Now, turn your gaze to Earth's orbit. Right now, thousands of satellites circle our planet. Most will fall and burn up within decades. But some, in stable high orbits, could remain for tens of thousands of years. A few might last millions. If our civilization ended tomorrow, those satellites would keep spinning in the void, silent witnesses to a species that reached for space and then vanished. Which brings us to the Black Night. In 1960, radar operators detected an object in polar orbit. No country had launched anything into that trajectory yet. Photos taken in 1998 during a space shuttle mission showed a dark, angular object tumbling through space. NASA said it was a thermal blanket lost during a spacewalk, but the object had been tracked for decades before that mission. Some claim it's been in orbit for 13,000 years, broadcasting signals at regular intervals. Most likely, it's space debris, a lost blanket, a discarded booster, a fragment of Cold War paranoia. But the legend endures because the logic is sound. If an ancient civilization reached orbit, some of their satellites would still be up there, silent, dead, tumbling, waiting to be found. Space doesn't just preserve footprints and satellites, it preserves intent. Every object we launch is a message that says, "We were here, we reached beyond our atmosphere, we tried." And if others tried before us, the evidence wouldn't be on Earth. It would be out there in the eternal archive, on airless moons, in stable orbits, buried in Martian dust. Space preserves what Earth erases. The question is, are we ready to look? And if we find something, are we ready for what it means? We've spent 5 chapters searching for evidence of lost civilizations, ancient spheres, radioactive isotopes, carbon spikes, extinction patterns, lunar anomalies. We've been looking backward into deep time, trying to find proof that others came before us. But here's the truth we've been avoiding. We don't need to dig into ancient rocks to find that evidence. We're creating it right now. Every nuclear test we've detonated has left isotopes in the soil that will be readable for millions of years. Every piece of plastic we've manufactured is embedding itself into sediments that will become future rock. Every ton of CO2 we've pumped into the atmosphere is writing our story into ice cores and ocean chemistry. We are actively becoming the anomaly that future geologists will puzzle over. In 10 million years, when every city has crumbled and every monument has turned to sand, scientists will drill into our layer and find exactly what we've been finding in ancient layers: sudden carbon spikes, radioactive signatures, synthetic polymers, mass extinction of large animals. They'll see the pattern and ask the same question we're asking now. What civilization did this? We are the mirror, and the reflection is terrifying. Because if ancient civilizations rose and fell before us, if they left behind the same fingerprints we're leaving, then we already know how their story ended. It ended in extinction, in collapse, in silence, and we're following the same path.